Hi, everybody. How are you guys? Welcome again to another Java talk. Here we have Rogerio. Here we have the our guest. We are like wrapping up our year with the call with the talk about a very interesting subject. Very interesting like topic to talk about. You know, database yet that we are not talking about AI, of course. We are done with AI. No more AI stuff. I think everybody was like going crazy with AI this year, but that's a really good end to end up this year with something about database and dealing with databases. It's being since beginning of Java. Java is the best place, to talk to databases. We've been learning a lot about Hibernate and this stuff. So I don't want really to take much of your time, guys. I hope you really enjoy this session. So please post your questions in the box below, and we'll try to take them on the way. And please, like, we need like to we need more questions from you guys. We need your collaboration. We need your to ask our guest tough questions. So he's ready to take all of them. Okay, without further ado, I would like to give the mic to Horio. So please, the mic is yours.
Thank you very much, Ali. Really appreciate the opportunity to be here with you guys today. The year is ending, like you said. This year has been crazy about AI, and I think this is a fresh subject, like you said, Ali, in relation to how can we do better with databases, right? Like we've had JDBC for decades now. It's a solid technology, but I think we never got the chance to try to move it forward, right? So that's what we are trying to do here at OpenJ Proxy. We're trying to give the next step on the JDBC connectivity kind of platform. We are not bound to Oracle, so I'm not speaking here about the JDBC itself, but we do use JDBC, and I'm going to be explaining how we use it in OpenJ Proxy. So if you have questions, just please send to Ali. I cannot see the chat here because I'm sharing and I see my presentation in full screen. But Ali, you can interrupt me at any moment and I'll answer the questions on the spot. You don't need to wait till the end. We can make this a conversation. If there are questions, we can drive this presentation more towards the questions that people have. All right. So with that said, this is our agenda for today. I'm not going to go through it like we're going to go through it during the presentation, but that's what you can expect. A small legal notice. This presentation and all the materials contained in it are free to use. Like if you guys want to use it in your workplace, college, or anywhere else, you can use it. The only thing is that I'm not responsible for how you use it, okay? So if you use it to do something bad, it's not my responsibility. That's the only thing that's in this legal notice. About myself, just quickly, I'm a father of two boys, so very busy. I hold a post-graduation in software engineering by the PUC Paraná. And I've been working with software engineering for more than 18 years now. Like I worked for some well-recognized companies like MasterCard, Huawei, Citibank, Bank of America, and currently I'm a lead software engineer for Bank of Ireland. I hold a TOGAF 9 certification, and I hold 4 more Java professional certifications. I'm the OJP founder. That's the capacity I'm speaking to you today, right? I started this project a few years ago, and this year we started putting code down, started creating versions, started a community, and that's what we're going to be talking about today. I'm also the author of Design Pattern Proposal for Outscaling Stateful Systems. This is an article that was published by the InfoQ in 2023. And I'm a blue belt in Brazilian Jiu-Jitsu. That's my hobby there. All right. 1 minute to talk about our partners, okay? These are people that have helped a lot the project till here. So the Comunidade Brasil JUG is another JUG, was the first community to embrace the project. And we're very grateful for their support. Switcher API is another open source project. If you want to do switches in production, like a flag feature switching, that's the project to look into. Meterian is from a Java Champion, our partner, and it's basically a way to scan your dependencies, right? Your open source dependencies and look for vulnerabilities. It's free to use in your IDE. Currently, they have support for VS Code, and it's very good. It found some vulnerabilities that we couldn't find with other tools in OJP. So we do use it in OJP, and it has helped us already to close some vulnerabilities. Cyberjar is a YouTube channel, okay, that it's one of the maybe the best quality in content for Java that I found online. It's very fresh. It's a new YouTube channel, and like check it out. You're not gonna regret it. Like the quality of the video, the sound, and the content, and the presenters, how knowledgeable and how good work they present is unmatched. And Java Challengers from our friend Rafael Del Nero, another Java champion. He's working with career development. So if you want to develop your career, that's the place to go, okay? He has a YouTube channel. He does a lot of work on LinkedIn as well, and he's mentoring people. So if you're looking for pushing your career forward, that's the place to look into. Right, and in relation to OJP, before we get into the needs and bobs of OJP, we need to remind ourselves of a few fundamental software engineering concepts, right? And one of them is that serialization beats parallelization. And that sounds weird, right, at the first glance. But that's true because we have limited amount of CPUs, right? So when we talk about parallelization, and let's say you start spinning up 50, 100 threads, and you only have 20 CPUs or 18 or 16, the real parallelization that you can do at the CPU level is those 16, 18, 20 CPUs, right? We do know that with virtual threads and how modern CPU and motherboards, etc., architectures, you can improve that. So you don't necessarily need to use only 16 or 20, the same number as your CPUs. You can use more. But if you use too much more, what starts happening is that you start losing performance because the CPU and starts using time to save state in memory and restoring state instead of doing work, right? Because if you have too many threads, you start using the CPU uses a little bit of time to bounce between these tasks, right? Like the guy in the right left side there, bouncing the stack and doing pauses and bringing memory from a different thread and starting a different thread. So juggling threads take a cost, and we want to avoid that, right? So we want to serialize more work so the CPU actually does work instead of switching between threads. So that's to remember here. And we go straight into an example, right? Like let's get a very basic example, very common example. A Spring Boot app connecting to a database, a relational database. Spring Boot by default has 10 connections, right? It uses Hikari CP as its connection pool. And Hikari CP is 10 connections by default. That's what we are using here, just for an example, right? Obviously, you wouldn't have only one instance, but just for our example, we're going to start with one. Let's say you start the demand for your service, whatever service that is in Spring Boot, start increasing someday, and you need to spin up more instances of this. Probably in your Kubernetes, you configure it to grow elastically, grow that application. And it started to grow. Now we have 30 connections hitting the database. Each of these apps have their own connection pool. So each of them is opening a maximum of 10 connections. Because you're busy, they are all with 10 connections. That's our assumption here for our example. Let's say some celebrity posted about your service, or whatever you sell online, or whatever is your service, and there is a surge, or it's Black Friday, right? Or it's a DOS attack. But the thing is, the demand is unusual, right? And it keeps growing. So by this time, we have already 5 instances of our microservice. They are hitting the database now with 50 connections instead of the initial 10 or 20 with 1 or 2 instances. So the database is starting to be very worried at this point. And in our example here, when it reaches 8 instances of this app, which is very unusual for this database, the database, died. So Uh, the example here is an increase on demand that doesn't stop, and it reaches a point where the database becomes unresponsive, which usually is timeouts, right? You start getting a lot of timeouts in your queries. So that situation comes mainly, this situation comes mainly from the new architectures that we have, right? This is basically what we do with microservices, right? Like Spring Boot is the most popular framework, I would say, for microservices, followed by Quarkus and Micronaut and Helidon now. So that's a common situation, right, that we face nowadays. Another situation would be lambdas, right, and serverless processing, that in which case you wouldn't need to even have the connection pools. You would be opening and closing connections all the time because you cannot have state in serverless or lambdas programming, right? You cannot hold something like a connection pool. And in those scenarios, the clouds usually provide you a proxy, right, to use with their databases. And there comes the problem, is with their databases. So if you start using their proxy, it's kind of, you start binding yourself to their technology and to their services. So it's not very free, right? There is no standard proxy yet. Maybe OJP is what will become the standard, we hope. So what questions we asked ourselves in relation before we created OJP, right? So how can we elastic scale our apps without overwhelming our databases? And so we don't need to over provision our database, because in this scenario here, we could have solved this by having an over provisioned database, right? So we could have a database that is massive and that we pay for that all year round, but that we don't really use the capacity most times of the year. We only use a few times of the year, but that's waste of resources, right? It's a waste of money. So how can we elastic scale our apps without having to overpay for database resources, right? That's one of the questions. How can we make a proxy, or how can we make it, OJP is a proxy, right? How can we make a proxy that's more compatible with different databases and with different clouds? Because I said before, like, you have AWS proxy or variations of that in other clouds, and you can use them, but you need to learn how to use those, and they are bound to one cloud. So if you use one of those and you want to migrate to another cloud, you don't know how the behavior will change. You need to learn how to configure it. There is an ops perspective on that as well. So there is no single solution that works in multiple clouds. And there is also no single proxy solution that works for multiple database types. Usually these solutions, they are bound to one database. For instance, PG Bouncer is a very popular proxy for Postgres. You probably heard of it already. It's a very good proxy, but it only works with Postgres. So if you want the same solution to work with Postgres and MySQL and Oracle and DB2 and SQL Server, it didn't exist, right? So another question is, can we create something that does that we can use a single solution for multiple databases, multiple clouds? How do we deliver seamless integration with Java apps? So we are Java developers. We want it to be easy to integrate this solution with Java apps. And how can we make it more open source than current solutions? Because like the cloud solutions, they're good to work in the cloud, but they're not, most of the time they're not open source. And like PG Bouncer is open source, but it's bound to one database, right? Can it be developed in Java? And can we have a connection pool as efficient as HIC-RCP? HIC-RCP is the most used connection pool. It comes by default with Spring Boot data, right? So if you're using Spring Boot and you don't change it, HIC-RCP is what you get as connection pool. So can we have a connection pool that's as efficient as HIC-RCP? And that's the solution we came with. So the solution is to create a proxy server, which we call OJP, right? Open J Proxy. That proxy server holds a HIC-RCP inside it. So it uses HIC-RCP. So for the question, can we have a connection pool as good as HIC-RCP? Why not to use HIC-RCP and leverage all its capabilities, its experience, all the battle tested um, library that it is Hikari CP. And we use JDBC then under the hood, under Hikari CP to connect to databases. What that gives us is that we can connect to any database that exposes a JDBC driver. So it makes us very database agnostic, because it's very hard to find any database that won't allow you to connect via JDBC, right? So, and to make it simpler for Java apps to connect to it, we also developed a Type 3 JDBC driver, which integrates seamlessly with Java applications, right? So for you to start using J Proxy, you just need to to start a OJP server and get your JDBC driver into your app. So that's basically it. We use gRPC to communicate between the driver and the proxy server, and we get all the capabilities of multiplexing in HTTP 2.0 there, right? So it's very efficient. Going forward, if we go back to our previous example, right, where we had 80 connections coming into the database, they would not come into the database anymore. They would go to OJP. OJP would deliver virtual connections to the apps at the app instances, and we would control only, let's say, 20 connections to the database, which is a very safe number for most database sizes. So when we see this diagram, we can see that the database is very happy because it's not being overwhelmed by like tons of connections. And that's what we want, right? We want to be able to elastic scale our applications, but to defend the database in a way. That's why our icon is a shield. We shield the database from overwhelming pressure. So we are back pressure mechanism at the core, and our main job is to defend the database. And we escalonate these connections very efficiently. I'm going to show you some results of our performance testing that is quite surprising, actually, how good the performance can be by serializing more the resources instead of parallelizing them with OJP. If there's any questions, Ali, please interrupt me, because if not, I keep going. Distributed monoliths, right? So probably all of us now, if you worked for a while in Java, you've experienced these apps that start breaking an old monolith into microservices, and it breaks down all these services like orders, billing, inventory, etc. And everything looks beautiful in the diagrams, right? But they all connect to the same database. So it's very hard to break down the database, right? So usually companies try to do a strangling pattern to leave the database for the end. But that means that for a big, quite long time, you're going to have multiple services connecting to the same database. And that creates, the type of pressure that we were talking before, right? So you have a single database, and now instead of one microservice, which was my example previously, now we have three, right? And those three can grow maybe to 10 instances each, and all of them will be hitting the same database. That's very common in many companies. With OJP, that you modernize this architecture already, right? Because of the benefits we already talked. If you put OJP in front of this single database, OJP will control a lot of this pressure and not let the database be overwhelmed by these multiple services. And I'm going to go through some of the details of OJP's implementation and things that help you defend the database even more. So very good for distributed monoliths, which is the reality. Sometimes people don't like this term, distributed monoliths, because it sounds like, oh, you didn't do the job, like it's missing parts, you didn't implement fully microservices. And that's reality, right? In many situations, you're going to work in scenarios where you need to deal with old technology, old architectures that integrate with newer architectures that integrate partially with newer approaches. And the distributed monolith is a very common situation that engineers find themselves into. So OJP is a good way to modernize a distributed monolith. It doesn't solve its problems fully, but it surely help a lot in relation to controlling the access to a single point of failure, which is the database, and a very important one. This is a comparison graph of OJP with the existing proxies, just to give you an idea. And that's maybe the biggest reason why we pursued implementing OJP and why we think it has a place in the market. All the blue ones are open source, all the red ones are proprietary, and the dotted ones are partially open source. So you can see Google Cloud Proxy there in the middle is partially open source. So as more in the vertical axis, it means that the proxy is more database agnostic, right? So OJP is the only one that gets 10 on that because it's the only one that can really interact with basically any database that supports JDBC, right? No other proxy that's in this list can do that. And no other proxy in the world, really, at the moment. And as more to the horizontal axis, more close to the 10th, is how open source proxy is. So we have pretty open source proxies like Proxy SQL, MaxScale, PG Bouncer, PG Pool 2. But you can see by the names that they are bound to one database already, right? Like PG Bouncer is Postgres, PG Pool 2 is Postgres, Proxy SQL is mostly MySQL, but now I think they support Postgres as well. So you can see that they are bound to a few families of databases and not open to a wider range of databases. These are some notes in relation to how OJP differs from the other proxies. So it's implemented in Java, right? Which is not usually the case. Usually these proxies are implemented in C, C++, usually the same language as the database, because they are implemented with the vision from the database, from the perspective of the database. I think OJP is one of the first attempts to give the proxy the point of view of the application layer more, right? OJP almost behave like a microservice itself. It's not. It's a proxy, right? But it's a layer 7 proxy. So it behaves, it operates at the application level. So it understands many things and can do more elaborated things than these proxies that sometimes operate at a network level and not at the higher levels. So we already talked about that, database agnosticism, cloud agnosticism. It's not just for Java. Because we use gRPC, right? We can compile the API that OJP uses and use it in other languages. It's not simple. I can tell that. It would be better if we created, like we created the JDBC driver for OJP, that we create, ADO.NET for .NET and create clients for OJP instead of trying to use it directly. But if your use case is simple, I would say that's very possible to just compile the gRPC and start using it. It depends how complex is your use case. Frictionless integration with Java apps. We talked about it. We deliver a JDBC Type 3 driver, the first open source in the world, I believe. I don't know about any other Type 3 JDBC driver that exists. And unprecedented freedom in the proxy landscape. And this freedom comes from, we are Apache 2.0, right? So it's completely free, completely open source. We don't charge anything for you to use the proxy, and it's not bound to any cloud and not bound to any database. So we believe the value proposition is on that, on the freedom that it gives. You learn to use OJP, and you can use it with multiple databases at the same time or separately as you wish. And once you learn how to use it, you can use it everywhere. That's the idea. Here is just an example. You can compile our protobuffers into different languages. Java is just one of them, and we compile it to Java, and then we use that client for the gRPC API into our JDBC driver, and it talks to the server via that gRPC protocol. Any questions there, Ali, before I move forward?
Yeah, there is one question here. Thank you. Question is saying that what if we adjust the database connections to remove the idle ones and the unused connections. Do we still do we still need to use any proxy for that?
Uh, if you well, if you have any idle connections, then you're not in the situation where that I described here, right? This situation here, there is no idle connections, right? The-
All right.
the- that's why we are spinning up more instances of the microservice. This scenario means that 10 is the maximum that we configured. We reach 10 and the app is under stress. So we spin up two more instances and it keeps growing, right? Like I said, it's a Black Friday or is some event that is growing on demand, right?
Mhm.
So the question is valid because it really depends on the size of your app and how much you expect to have in the future. If you don't expect your app to grow, that's a mid-size, is something for to run a limited amount of connections that is never going to grow excessively, then you don't need a proxy, right? I would say you don't need a proxy with microservices, because with lambdas, you still need a proxy, right? Like with lambdas, let's say in AWS lambdas, you're always going to use the AWS proxy because you want to have a connection pool. And why is that? Because opening connections with the database is expensive. So you don't want to be opening and closing a connection every time you need to run a SQL to the database. That's why we use connection pools. But with lambdas and serverless, we cannot use connection pools because they may turn off, right? If nobody's using that specific lambda or serverless process, they are turned off. So there is no point on having a connection pool, because if the app turns off, and they need, by definition, they need to be stateless. And a connection pool is a lightly state, right? You need to keep that connection live. It cannot turn off. So
Yeah.
to answer your question, you don't always need a proxy. That's for sure. It depends on how much you expect to grow. Usually applications that expect fast growth or that experience this volatility in demand, that demand can be quite volatile throughout the year, they like the idea of using a proxy because of the situations I explained before in relation to have this back pressure mechanism. So if extra pressure comes, instead of throwing that pressure in the database and making the database doing this jungling here that we talked about before, because the database will, if you push too many connections to the database, you're not going to be doing just the work of doing inserts, updates, deletes, etc. You're going to be having to switch between threads, exactly like the CPU does. At low level, the CPU will be doing that, but also the database will have to control all those connections. It will use a bit more memory, more CPU, just to control. And in the end, it will have to serialize those requests, right? A lot of them, because it cannot do everything in parallel. At the end of the day, it has a limited amount of CPU cores, and it will have to serialize requests. What we try to do as a proxy, right, as an efficient proxy, is to serialize more these requests before they touch the database. So when the database gets it, it gets a steady and stable flow of requests, and it can work on them. It doesn't need to be controlling like a bunch of parallel requests that was not designed to control. That's the main discrepancy between the modern architectures that we say, oh, we can elastic scale, but database cannot elastic scale that easily, right? Most of most of databases, they require, even if it's a short, they require a stop start before you can resize them, and it's usually a resize on size, right? It's a horizontal, not sorry, a vertical increase on the machine, not putting new nodes for the database. And what I meant to say with that is it's a lot harder to scale or to auto scale a database, a stateful system, any stateful system. That's my article about, actually, some ideas on how could we do it better. And because it's so hard, it makes sense to have this in the middle. That's why proxies exist. And we felt that the solutions for proxies that existed before, didn't fully fit what we as Java developers expect from a proxy, and that's what OJP stands for. Hope that answers the question. If there's any part I didn't answer, please
Yes.
send again.
Yeah, it does. It does. But still, I have maybe the question is correlated to that.
Yeah.
Still, if my service has already spent up with 50 more connections, okay, and those 50 more connections, we need to acquire them from the database. So if I bring the proxy in the middle, how also the proxy will help me if I want in that moment 50 also connections?
Well, if you want, let's say, if is 50 the maximum connections you want the database to have? Is that your number?
Yes.
So yeah, with the proxy, what's gonna happen here is that you're gonna put 50 between the proxy and the database, and your apps actually can get hundreds of connections, because then connections becomes cheap, okay? Because they are virtual connections. So you can send as many requests through as many connections as you want to the proxy, and the proxy will organize this and send them linearly through these 50 connections that you define being the maximum to the database. Doesn't mean it's gonna keep 50 connection open. Is a normal connection pool, right? Is HICRCP. You can establish, say, or start with 5 and you can grow to 50, or start with 20 and you can grow to 50. It depends on how warm you want your system to be, right? If it's a high throughput system, you probably want to start with 50 and keep 50, right? Min and max as 50, and then you let your apps open as many connections as they want to the proxy. You don't have connection pools anymore in the apps. If you use OJP, you need to turn off your connection pools in the apps. So for the app, it believes it's opening and closing connections, but it's not really, because as we have a gRPC pipes, we keep the gRPC pipe open all the time. So when the app thinks it's opening and closing connections, it's not really. It's just allocating one from the pool and returning it to the pool, right, in the server side. We also don't allocate the connection when you ask for one. Let's say when you're doing a JDBC statement, right? The first thing you ask, you get a connection, and then you create a statement, and then you set the parameters, and then you execute the query. We don't allocate a connection until the very last moment when you ask us to execute a query. So that little time between when you get the connection, the virtual connection, you set your parameters, you create your SQL, and you prepare everything to execute, there is no connection to the database yet allocated. That little bit of we save in each request, right? Because we don't give the connection right away. That's one of the ways we save some time and can reuse the connection more efficiently.
Yeah, sounds good. Yes.
Right. Circuit breaker. So in our first test with OJP, we noticed that if you have a query that is constantly failing, that degrades the overall performance of the whole system, right? And that can be a poison query. It can be a mistaken query, a bug, and you should fix. I'm not saying that because you use OJP, you should leave bad queries in your system or bugs. But sometimes we are humans. People don't test all the scenarios. We forget some scenario and goes to production. Some scenario, for example, that does a calculation in the query that doesn't expect a column to be zero. It should never be zero. It's some amount or something that should be always bigger than zero. But for some bug in some other system, that value went to zero in some scenario. And then you end up with a division by zero. Just an example, right? Every time that query hits the database, it's going to fail until you fix the code, right? You push a fix to production, etc. So if you don't have a circuit breaker, that query keeps going to the database, but we already know that it's going to fail all the time. So what we did, we implemented a circuit breaker, and that circuit breaker monitors all the queries. So all the green lines you see in the screen are queries that are good, they are executing, they're not failing. But if one query starts failing repeatedly, we start to monitor that query. And if it passes a threshold, which by default is 3 times, if the same query fails 3 times in a row, we open the circuit breaker and we block that query from going to the database. So the app keeps sending that query, but instead of sending it to the database, because we already know that it's going to fail, we just send the last error that we got from the database, right? We save the last error and we send back to the app. So from the app perspective, it's getting the same error that you would. But from the database perspective, it doesn't need to deal with that query that's poison anymore. And that saves the database a bit more effort to put into queries that are good and running fine. Another scenario where this happens is when the database is under stress, right? And it starts to time out requests. If you have experienced this in your career, where database, one of the clear signs that the database is under stress is that you start seeing timeout requests, right? Because the queries take too long to execute and they start timing out. If the database is under stress, you start getting a lot of these queries timing out, and usually the heavier ones, right? If you keep sending those queries to the database, what can happen is that the database may go belly up, right? It can fall down and not recover. And then is the worst case scenario you can have in production, right? Your database is down, that you need to restart, you need to engage people maybe at midnight or 3 a.m. to restart, to do checks. And if it's a node application, there can be scenarios that the application needs to be restarted because it doesn't reconnect automatically. So it can be a nightmare, right? With a circuit breaker, that becomes less likely, because when these timeouts starts happening and they reach the threshold, OJP doesn't send these queries anymore to the database. It will fail the queries, right? But the trade-off here is that you fail some queries and survive instead of dying, right? So OJP is designed to help in extreme scenarios, in high demands, in scenarios where if you didn't have OJP, maybe your database would go even down or become unresponsive. And that's what we want to avoid, right? We want more stability, reliability, especially for the database, because the database is harder to scale on demand. And if you over provision it, you're you're paying for something you don't use, right? So you want to use your database to the best of the load you expect. And if you get extra load, that will not overwhelm your database, that you will be able to cope with it, right? So once that query is blocked, there is a time window. I believe it's a minute by default. You can configure all these parameters I'm saying. You can configure, it's all configurable for your scenarios. You can even disable the circuit breaker if you say like, no, like I want all the queries going to the database. I don't care. Like I take responsibility. You can disable it. Everything that I'm showing here, you can enable, disable. Everything is configurable. But if it is there, it's active by default, and it blocked one query. After the time window, it will send one query, right? It's going to go to a half open state. That's standard circuit breaking behavior. And if that query succeeds, then it opens again, right? It closes again because it's circuit breaker, right? So it's open means not sending, close means sending queries. So that's our circuit breaker. It gave amazingly better results when failing queries are included in the tests. Like it just changed the game for OJP really on the performance tests. So we did a performance test earlier on. I'll show you here the results. So the test was with 2 small droplets in the DigitalOcean with 1 virtual CPU each. We ran 100 threads, so some multitude of CRUD requests, so selects, joins, aggregates, updates, 67 different ones, right, with a ramp up of 1 minute. Sorry. So in 100 threads, right? Let's say 100 customers at once in a ramp up of 1 minute, hitting a very small database, 1 CPU, right? So the failure simulation, we added in purpose 1 query that always fail, so we could test the circuit breaker, right? So there is a division by 0 in one of these queries that always fails. The focus here was in testing the connection pooling, circuit breaker, and we left the logging at minimal, right? So just error logging. And the results of that are this. They were quite surprising, quite amazing. So the total queries executed was 6,700 in 1 minute, right? A ramp up. The test duration with OJP was 64 seconds. So the ramp up is 1 minute. So how long did the test take to execute all those 6,700 queries? With OJP, it took 64 seconds. Without OJP, it took 80 seconds. Because you need to remember, the database needs now to get all those queries at once. It needs to deal with all of them. It spends time and effort doing things that are not statements. It also needs to deal with that query that's poison, right? There is no circuit breaker in front. If you're not using OJP, no circuit breaker, that query is hitting the database every time. So the database showed distress, and that was the target of the test. We didn't do it until it broke. There is another test I can show quickly as well. But you can see the CPU there with OJP, that's the database CPU, and with direct connections. And that's the difference, those two mountains there here, right? It's very substantial. Average query duration, so with OJP, 31 milliseconds, without OJP, 55 average query duration, because as said before, we put enough load to put the database under pressure. And when it's under pressure and you put OJP, it makes massive difference. That's what the test shows. Query failures, so 100 in both scenarios, because as I said, 100 threads. In each thread, we put in purpose one query that was poisoned, that would fail. We knew it would fail. And the max CPU usage used was 14.8 with OJP and 61.1 without, with an average of 10 with OJP and 41 without it, right? So that's a substantial difference. I'll just open LinkedIn here real quick and show you the other. Apologies, I need to do a few clicks here to get the other article, which is an extension of this test. Just bear with me for one quick second here. Where is it? Yeah, we'll open J Proxy. Just we did an extension of this test, this performance test, and that is even more impressive than this. That's why I just want to take the time to go there. Page. Let me just see here, articles. For that, I think I'm streaming. If it doesn't open, I'll send you the link later, because I'm clicking here. It's not really going. And just close some of these Chrome tabs. I think I have too many. Are you hearing me all right? Let me just kill one of these. I think it's taking too much memory here. Let me close this. I think it's. Give me 1 second, guys. I'll just close a few tabs here to get this in a better. Just 1 second. Usually it's fine to have a lot of this, but because of the streaming, I think it's taking too much resources. Let me go again to the page. Should be faster now. Yeah, open J Proxy. wrong click. Apologies. Usually this is super fast. For I think the stream gets a lot of my bandwidth, and it's just taking atrocious time for each click. But we'll get there. We'll get there.
No worries, Origo. You can send it later and in the post that you can post. No worries.
Yeah, if I cannot get it now here, I'll
Sure,
send it
sure, no worries.
later.
I think you need to apply OG proxy for your LinkedIn.
Yeah, here is the test. Yeah, so it's the same test as the previous one, but instead of using just 100 threads, we started with one thread, and then we grow to 25, 50, 75, 100 again, 125, 150, 175, and 200 threads. And we basically did that without OJP until we could break that database. So this test, we went, okay, how many threads do we need to break that single CPU Postgres, right? And that happened around 150 threads. You can see there in the table. It started failing, right? So you see the column failures, 229 failures when we used 150 threads without OJP, right? Just direct connections and without any other pool that worth mentioning. So it's a situation like a Lambda situation, for example. But and you can see that without OJP, the average duration grows, right? It grows in a linear manner. But with OJP, it remains very stable, incredibly stable, even at 200 threads, right? At 200 threads, the average query duration was 77 milliseconds. And to be honest, was not our focus. Our focus was in relation to creating stability. We didn't expect that OJP would be so much faster than not using it. So it was surprising for us, these results, and very encouraging. I think we need more tests, more different types of tests to show it in different scenarios. I don't think we're going to be faster in every scenario, but in this scenario, it was quite surprising. Even in one thread, which that is the most surprising for me, because I thought only one thread, which is 68 statements, right? We were already faster than not using OJP. And that for me is fabulous, because I thought, because we have the proxy in the middle, right, is an extra network hoop, I thought we would be slower, but no, even in that scenario, we were faster. Anyway, our demo, right? So I have prepared a demo here. I just need to see if this is working real quick, because I was having a bit of trouble to get the cache clean before the presentation. So let me just see. So this is a Spring Boot app. We have this project in our OJP framework integration repository. So it's a basic Spring Boot app. It's a shop service, so you can see their products, orders, all the reviews. So it's a very simple shop service, right? Like an online shop service. This is failing now. Let me just see if I can also increase the size of this. I think there was a setting here, which is font, if I'm not mistaken. I think there is a shortcut. Is South. Is it better? A bit bigger, huh? And let me just see why is it failing. Because this comes with OJP, right? So I had to remove it, OJP, for this demo, and I probably forgot to remove something. Yeah, I cannot find the driver class. That was the problem I saw before. It's just, I thought it was just a caching issue. So let's just see if it's in the class path. It's not. Okay, that's the issue. Page 2. The dependency is here. Let's just refresh it. And rebuild the project. It's not. Why is it not? Okay, I broke the POM. Let me fix it. H2. Is it the right? It's incorrect. That's the issue. Okay, I thought it was. I didn't check. That's why I need to always check these things. I thought I remembered, which is a mistake, right? It's just org h2 driver, not org to JDBC driver. Okay, and now it should work. Let's see. Yeah, all tests are passing, right? So it's a basic Spring Boot application which uses JPA, Hibernate, and uses H2 in memory database, just to be simpler, right? So we have our configurations here. For this example, there is 2 data sources, right? A lot of applications will have just one, but just to show that OJP can be configured for more than one data source, we put two data sources here in Spring, and we're going to do the same when we introduce OJP. So OJP, let's go to the documentation. I'll start from the home page here so you can follow along and you see where these documents are. So this is our front page in GitHub, right? If you look for J Proxy, this is what you're going to see. The first thing we need to do, we need to have our OJP server running, right? And the easiest way to do that is by running it in Docker. So that's what we're going to do here. Clear Docker PS. Let me just see. I think I had it running before. Yeah, I killed it. And let me just, I probably can increase the size of this as well, so it's easier for you to see. Yeah, much better. So let's run OJP server in a Docker container. There it is. Docker PS to see if it's running. Yeah, there it is. So that step is done. What we need to do now, this situation is like you have a Spring Boot app and you want to test it with OJP, right? That's what we are doing here. So you need to put our JDBC driver in your app instead of the one that you're using. So let's come here. Let's add the OJP JDBC driver to our dependencies. You probably could remove this. I won't here just for the sake of, it's just for our demo, but you're going to be able to remove your previous driver, right? You're not going to need it anymore. And the third step here, we need to point to OJP, right? Because now we have an OJP running at localhost. The full port is 1059. So what we need to do is we need to put this prefix in our connection URL. So if we come here to our application properties, just before the name of the database, we need to put the prefix OJP and where is it running and in which port. That's the syntax. Very easy. And just one more thing here, because we have 2 data sources, we need to give a name to at least one of them, right? So this one up here, we're going to name high performance. And that you're going to see in a bit where we can set different things for each of them. We need to use the 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 OJP JDBC driver, right, instead of H2. So we're gonna replace it here in both our data sources. And if you want a detailed documentation on a framework, because this is just the generic steps you can do, right, to run OJP and doesn't talk about frameworks. But if you come here at our documents and you come here at Java frameworks, you're going to be able to see the exact steps for each of these frameworks. And if you use another framework and you want to contribute how to configure in your framework, please do. Like we want to increase this. But for our case here, Spring Boot, right? So we already did this step. You see, we didn't do this step. So we need to exclude HIC-RCP from the app, because now we are basically outsourcing the connection pool to this OJP server. So we no longer need to have HIC-RCP into the app itself. So let's just find the Spring Boot starter. There it is. And we're going to put this exclusion here. And we're going to exclude HIC-RCP locally. And because we excluded HIC-RCP locally, we need to do just one more step here. And we need to put this simple driver data source. And that's because if we exclude the HIC-RCP, now you need to tell the Spring Boot app how it should create connections, right? And this is just a basic data source that just opens and closes connections. It doesn't do any connection pool. So we just need to name it correctly, because let's get here. So Spring data source checkout. It needs, for this one here, it needs to be checkout. So we have a high performance data source, which is our catalog here. In Spring, it's called catalog. In OJP, we call it high performance. I left the different names just in purpose. You can use the same names. It doesn't need to be different, but just to show that it's not tied to Spring stuff. So you can use any names you want. Now we are pretty much ready. Just one more detail. If you want to configure your connection pool, and we do because we have two data sources, you're going to have to create a little file here called OJP properties to be able to, and you create it under your resources folder, right? Regardless of, or your root folder, source root folder, or resources folder. And that's unnecessary. If we left it without, we would get the default. So if you're just testing, you don't need to create this. I'm just going one step forward to show that because we are using two different data sources, we can configure them differently, right? So let's say our high performance one, I think there was a question there, like, oh, what if I need more connections? So you can create two different data sources, like one for high performance, which you keep minimum of 10 and maximum of 50, and the timeout is longer. And a default one, which is smaller and times out faster. So you could have this situation, right, where you separate your application in two data sources, and one is super fast and the other one, it has less resources. So that's what we just did here. I think we are good to rerun the test now. Let's just make sure that this, because we changed the dependencies, I'll just reload it and do one build. And we should be good. The expectation is that we're going to run the same test, and the test we're going to pass, right? But now it's going to be going through OJP. It's not going to connect directly to H2, a database. So let's just run the test. Fingers crossed. Yeah, so that proves that, you see, super simple to integrate, and just for fun, let's Docker stop our OJP server. Admiring Docker PS. So OJP server is no longer running, just to show that it was connecting through the OJP server, right? So it should fail now. Yeah, and the failure is unavailable, right? So it couldn't find OJP server. So that's our demo. If there is any questions, please shoot, and I can answer any questions in relation to the demo. Here's the documentation, right, where you can find it. We went through it, so I'm not going to go again. If there is no questions, I'll go into another very cool thing we did in OJP. And this is a novel thing that nobody has, because everything I explain here, like one or another proxy might have parts of it. What I'm going to explain now, like nobody has. It's completely new. It was created and developed only in OJP to sort a very common problem of connection pool, actually. So we call it this low query segregation approach. It's basically a smart bulkhead. If you know the bulkhead pattern, it's like a dynamic and adaptable bulkhead. But because it's so difficult even to say adaptable dynamic bulkhead, we just call it slow query segregation. Because in our scenario, that's exactly what it does. So imagine your connection pool being a highway, right? Like the figure there, like the picture there. You might end up with slow queries clogging your connection pool. And if you have too many slow queries, they make the fast queries wait. And that's exactly the example in the highway there. If there is no organization, your fast cars will have to wait behind slow trucks and tractors. So what we created is we divide the connection pool in two sections, and the slow query section and the fast query section. And we use a very cheap algorithm to keep a rolling average of every query executed against the database. And that's how we know what is slow and fast. So first we measure how fast are each query, and then we separate them into two sections in the connection pool. By default, the slow query section is 20% of the pool, and the fast section is 80%. And so all the slow queries we send to those 20% of the pool, and the fast queries can use 80% of our pool. This doesn't exist anywhere. It's completely new. It's completely created in OJP. And there is an article about it in our LinkedIn page, in the article section. If you want to know more how exactly this was done, you can go there and dig a bit. Or if you have questions now, I can answer now for sure. Ali, any more questions there before we start wrapping up?
No more questions. I think everything is good. Sounds good, yes.
Okay, yeah. So wrapping up, please help our project to grow, right? This big QR code there in the corner there, you can scan there and give us a star on GitHub right away. That help us, right? More stars in GitHub means people are liking the project. They think the project is interesting. Please try yourself. Report to us, like if you have any difficulties, like if you're struggling with something. We have a Discord, which the link is there. We recommend you can deploy already in production with OJP. We recommend deployments in production for non-critical applications for now. So that's the recommendation. Internal non-critical applications you can deploy to production. We just released clustering, so you can deploy more than one OJP server, and the type 3 JDBC driver can load balance and fail over between multiple instances of OJP servers. So it's very robust. Our version 0.3.0 beta, and now we are in 0.3.1 beta, but since 0.3.0 beta, we are capable of doing clustering. If you want to help the project, join our Discord. You can produce content about OJP. Share. It's very important that people share about OJP in their networks to grow visibility, right? Those are our platforms. So we have a Discord, a LinkedIn page, And my personal X is also used for spreading news about OJP. And we created this badge recognition program. So if you do share things about OJP or you produce any content, even if you just share in your LinkedIn once, you can get a badge that you contributed to the project. It's not just code. That's why we created this, because an open source project is more than code. So we wanted to reward efforts that are not related to code as well. So code is here, obviously. It's the first one is in blue. So you can get badges as an OJP contributor, developer, core developer, right? As more you contribute, you grow. It's like a mountain, right? You start growing into the community. But we also wanted to reward like testing and quality, evangelism and community, right? So if you help to spread OJP, you give talks about it, or you just share on your network consistently, you grow in that line. Or if you don't like doing any of that, but you like writing, we need people to write our documentation, to rewrite, to organize things, publish articles about it. So the knowledge part is the orange part there. And once you grow in this, you can reach the OJP champion, which is a straight out copy of the Java champion, right? So that is inspired by the Java champion and like Vaadin champion, like kind of programs. But it's our own. So if you help the project, you get one of these badges, and you can publish it right away to your LinkedIn. So if you click in the badge here, you're going to see that it opens LinkedIn and it is ready to publish. For some reason, LinkedIn is, you see, you get the badge ready to put in your license or certification with the link to that page. One thing I didn't show in that page is that your name is in the page, right? So everyone that contributes is named here. So you can see all the names here, the link to their LinkedIn. So if you put this in your CV or in your LinkedIn, and the person clicks and come here, they're gonna see your name. So it's a way to to show that you help in open source projects. A very cool way, in my opinion. Rafael Del Nero, the Java champion, I was talking to you, Ali. The Ali knows as well. Thinks this is a great idea. It's a way to to reward people that help in the project, not just in code. That's it, guys. If there is any more questions, I'm ready to respond to them. If there isn't, I'd like to thank again Ali for the opportunity to be here, and thanks for all your work in the Java user group. The Java user groups are an amazing type of organization, and it's really impressive to me the work you guys do. I think Java is only relevant because guys like you and your Java user group, it's very important, I think, for the community. It's very important for projects like us that don't have any sponsorships or anything. We have partners, but there is only people that believe in the project. And the Java user groups have been an amazing channel for us to show the project, and they only exist because of people like you, Ali, and others that organize the group. So thank you very much for the work you do there. And if there is any more questions, if not, I'm wrapping up with the presentation. That's the content I had prepared for.
Yeah, thank you so much. That was really, really amazing and opens up the eyes to so many other stuff, really. I was really astonished by this amazing stuff you guys doing. Really tremendous job. So before we wrap up this talk, I would like also to thank you so much for also accepting our invitation, and also thanking all the audience for their contribution here, and also looking forward for the next year, of course, to host you for more other talks. Yes, without, if you have any final words, thank you so much.
No final words. I'll just stop sharing here for a moment. I think that and go back because I was not seeing you, Ali. Now I can see you. My final words is, guys, yeah, like Ali was saying, like everything is about AI. This is foundation technology. Like we are using AI a lot. That's something funny because you said a lot about AI. We leverage a lot of AI capabilities to build this project. So we do all the analysis ourselves, but we do leverage like bots to write code, to write some unit tests. So it speeds up a lot. I think this project is the speed of development has been amazing, because basically you can go to sleep and leave Copilot coding for you. So that didn't exist before, right? So OJP doesn't incorporate AI yet. We are thinking about opportunities, but we don't want to put AI just to put. We are building foundational technology. I think I think everyone is excited about AI, and we are using AI. We are also excited about it, but somebody needs to be doing this foundational work, which is creating like a proxy for a database. What we are doing, right? So which is more like layering bricks, I would say, in the house, instead of instead of putting
Yeah.
the shiny windows.
Yes, exactly. Yes. Sure,
Well,
sure.
thanks,
Okay.
Ali. Really appreciate it. It was a pleasure to join you here, and
Yeah.
surely next year we're gonna do
Sure, sure,
another one.
sure. Just a question, maybe most of the like community members asking our like hosts when we bring like speakers, what AI agent tool are you using and you're recommending? Yes.
I'm using a lot GitHub Copilot. And I use the ChatGPT itself, like just as a chat. So what
Mm,
I've been doing a lot is I love how Copilot uses ChatGPT, right? It can use many engines, right? So you can choose the engine or leave it automatically. Usually I leave it automatically. Uh, what I noticed is that you need to keep an eye on Copilot, right? Because
yes,
sometimes it resolves the problem in the wrong way. And I can give you an example that happened to me.
exactly.
There was a test failing, and Copilot, instead of fixing the test, it kind of make the test useless, right? So the test would pass, but it wouldn't test anything anymore. And these things you need to be careful, because
Yes,
sometimes you just leave to the AI to do the work. You cannot do that. Maybe in the future we will be able to do it. We cannot right now. Like, it's very productive if you give the description, but you need to come back and check. So I feel like I read a few articles about it. Like, validating the work of AI is very massive at the moment. So it's very
exactly. Yes,
productive. It's amazing. It helps you. It helps me a lot on doing the designs, because it has all the knowledge of the world, right? So when I ask a question, it brings me knowledge. So when I'm doing a design, like for instance, this low query segregation, it gave me a lot of insights until I got the exact idea that would help OJP case, right? It didn't give me the idea, but it give you the bits that help you to in a conversation. It's like talking to a super smart guy, right?
exactly.
I use a lot that, and I use a lot the Copilot capability of you give it a task and go to sleep, right? So it works 24 hours. So that's amazing. So those are the things I'm using the most, and but you cannot think that it's gonna do everything. In some scenarios, I left it do more to see if it would be able to, but in the end, I
Mm,
spent a lot of time trying to fix then the work that he did, and I had to throw away. I have to throw away 40% of the work that the Copilot does. That's
yes,
more or less
indeed.
this. But I think it speeds up the development of the project by 5 times. Like, it's like having 5 developers working nonstop.
Yes,
Uh, so you throw a lot of things out, but you still keep a lot of things. And the things that you keep is amazing. Like, things that would take weeks for a person to develop, Copilot will do in 20 minutes, right? Is that right or not? That's the part that I find hard to. You need to validate. You need to be constantly reviewing carefully what Copilot is doing, or any AI tool, really.
yeah. Sorry, maybe I was just
There
disconnected
was a
for a
glitch.
couple of seconds. Yeah, yeah. Yeah, I think that's a well noted point that we have to be careful when we use AI. Yes, we have to be very careful. Yes.
Especially if you're developing a proxy, right? So I don't merge any code that I didn't review line by line. So you're gonna see a lot of commits from Copilot, because I wrote the core of this project, but then when I learned how to use Copilot. Now I let Copilot do more of the coding, but I review line by line, because I saw that I cannot let Copilot drive. And it's good to speed up, but it needs to be reviewed line by line.
Hmm. Nice. Very good. Very good. Very good insights. Thank you so much, Radio. Thank you so much. Really appreciate your time. Appreciate your knowledge. So, thank you so much. Looking forward to see you next year.
Thank you very much. Appreciate it. Appreciate the guys that are online for the questions as well. Very good questions, very good level. I really appreciate all these questions. Help us to improve OJP. Many of the questions, drive how we approach things and where we see that people have more pain. If you want to participate more, please be invited to come to our Discord. Discord is our open room. There is no stupid questions. We are a very friendly community, a small community for now, but we are growing fast. So if you want to get a project that is in the beginning that you can really make a difference, that's the project. Right? Like you cannot get the Apache Tomcat in the beginning anymore, but OJP you can.
Yeah, yeah. Thank you so much. All right. So, you guys, thank you so much for joining us.
Thank you.
Thank you.